Hello everyone. Today we're going to look at usaco-training sweet butter. Okay, so let's take a look at the problem statement. Okay, so Farmer John has discovered the secret to making the sweetest butter in all of Wisconsin sugar. So when he places a sugar cube in the pastures, he knows that his end cows would go to that pasture, or in other words, would lick it or lick the sugar cube. Okay, so then we know that there's N cows, and we know that there's P pastures, and the N cows would be basically distributed in those P pastures. And there are C edges or C paths that contain or that connect two pastures, where each path contain a distance. So, for example, if we take a look at the input, you can see that path number 1 connects pasture 1 and 2, and it takes a total of 1 unit of distance to traverse this path. Okay, so, and the second one would be connecting 1 and 3, or pasture 1 and 3, with a distance of 5. Okay, so then, as you can see here, we're given the positions, or where the cows are located in the pastures. Okay, so let's actually describe more of the problem. So let's just say that Farmer John is going to place the sugar cube at pasture 1. So the first cow, which is at pasture 2, would walk 1 unit of distance. The second cow, which is at pasture 3, would walk a total of 5 units of distance. And the third cow, which is at pasture 4, would walk a total of 3 plus 1, which would be 4 units of distance. And when you sum this up, you would get a total of 10 units of distance, which really isn't the optimal answer. So the optimal answer would to be placing the sugar cube at the 4th pasture. Then the first cow would walk a total of 3 units of distance. The second cow would walk a total, which is at pasture 3, would walk a total of 5 units of distance. And the third cow, which is already at the pasture, would not walk anything. So then the minimum distance the cows have to be walked in this case would be 8. All right. So notice that there's only a total of 500 pastures. And let's just basically review some shortest paths algorithm. So we know that Dijkstra, this runs in O of V log. It would be V log M, or basically, my bad, V log V plus M, where V is the number of nodes, and M is the number of edges. And what Dijkstra does is that Dijkstra calculates the shortest distance from X to any other node. Okay, so for example, if I run Dijkstra from pasture 1, then I would get the shortest distance from 1 to any other pasture. And notice that since P over here is very small, then we can basically simulate placing the sugar cube at all the P pastures. So for example, let's call or in this case, let me just draw out the graph. So we have pasture 1, we have pasture 2, 3, and 4. So we have here, this is 1, here this is 5, 7, 3, and 5. And green means that there's a cow over here. Okay. So in this case, we would simulate placing, whoops, how do I draw here? 1 second. Alright. So over here, we would simulate, let's just say we want to place at 1. So then, if we try to do this, then we would basically run a Dijkstra from 1. So then, if we try this, then let me actually use green here. So we would have 1. Your shortest distance to 2 would be 1, because you would just take this path. Over here you have 5. Okay, and then you basically would not have this edge, basically. And over here, let's actually just draw that. You have a 4, and my bad, so that isn't actually 3. So the shortest distance from 1 to 4 would be a total of 4 units of distance, which would contain this and this. So then this, or this is actually a bad way of modeling this. So we can call our distance. So distance of 1 will be equal to 0, because you know it takes 0 units of distance to reach from pasture 1 to pasture 1. Distance of 2 would be equal to 1, since you can just take this path. Distance of, whoops, I'm using crayon. So distance of 3 will be equal to 5 units, since you can take this path. And distance of 4 would be equal to 4, since you could take this path and this path, which would be 1 plus 3, which would be equal to 4. Okay, so now that after you run Dijkstra on from 1, where you're going to end up is basically you have this distance array, and basically how are you going to use this to find a possible answer. So you know that at pasture 1 you have 0 cows. So we have, let's actually use here, so we have 0 cows. At pasture 2 we have 1 cow. At pasture 3 you have 1 cow. And at pasture 4 you also have 1 cow. And then what we're going to do is that we're just going to multiply each of these together. And then our sum over here would be a total of 0 plus 1 plus 1 plus 5 plus 4, which would be equal to 10. And why does this work? Basically, since you know that we have, let's call this D and let's call this X. So if we have X cows, then it means that we have basically X cows going from this specific pasture to pasture 1 in this case. And since all cows would want to take the shortest path, which is described by our distance over here, if we multiply these together, we would basically get the total distance covered by each cow. Okay, so now that's just placing it at 1, or placing the sugar cube at 1. So then what we're going to do next is that we're going to try placing at 2. Okay, so if we place it at 2, then our distance of 1 would be equal to, let's look up here, you could take this path, so then this would be 1. Distance of 2 would be equal to 0, since you can just stay at your position. Distance of 3 would be equal to a total of 6. And notice that you wouldn't take the 7 since it would be longer. Right, whoops, so this would be 0. Distance of 3 equals to 6. And and let's just write it here. So distance 4 would be equal to a total of 3 units of distance. So again, you would multiply this by 0, by 1, by 1, by 1, and you would end up with 6 plus 3, which would be equal to 9. So again, you see that, whoa, that is a better answer than placing it at 1. So you may want to update your answer. Okay, so then basically we would basically simulate placing the turkey cube at each of these end pastures. So right now what we've done is that we have already tried placing it at 1, and we also tried placing it at 2. And in your program, you should try placing it at 3 and at 4. So I'm just going to demonstrate placing it at 4. So we're going to be placing at 4. All right. So then your distance of 1 would be equal to, let's look up here. This would be equal to a total of 4 units of distance. Distance of 2 would be equal to a total of 3 units of distance. Distance of 3 would be equal to 5 units of distance. And distance of 4 would be equal to 0. So then again, you multiply this by 0, by 1, by 1, by 1. You would get 0, 3, 5, and 0. You sum it up, you would get 8, which is your optimal answer in this case. Okay, so let's actually go implement this, and let's get to our code. So let's include bits. All right, so we're going to define the total number of nodes, and this is going to be n, which is at most going to be 800. All right, so we're going to have our main function. So let's actually look back at the problem. So n, p, and c. So n is the number of cows, p is the number of pastures, and c is the number of paths. So let's actually go over here. So we have n, p, c. Okay, so we're gonna read. Let's actually just speed up our input. So n, p, and c. So in the following lines, we're going to read at the number of cows in it. So let's call this CC. So this is going to be number of cows in CI, or CCI. So then we're just going to loop through each cow. We're going to read the cow, and we're just going to increment the number of cows at pasture J. So now after this, we're going to read in the C paths. Okay. So in this, we're going to be given A, B, and W, or actually D. So A, B is the 2 pastures, and D is the distance. So we're going to read A, B, and D. Okay, so to represent this, we can use a vector of a pair integer. So let's actually using pi equals pair int. So okay, we can just use pi here, and let's call this graph. So we have ADJ, or adjacency list. So we have n nodes, and so let's just call this our edges. Okay, so then we're going to do ADJ of A. Since the edges are bidirectional, meaning that it can go both ways, we're going to insert them 2 times. from each one. So AJB dot pushback AD. Alright. Okay, so now we're basically done reading the input. So now we're going to try basically dictioning from all and we're going to try dictioning from all P pastures. Okay, so let's have a function. So let's call this X, where X is going to be our source. Or let's actually call this source. Okay. So we're going to basically have a priority queue. And what I'm going to do here is I'm just going to make this a little bit easier. So I'm just going to make this PQG. So this, since in C++, a normal priority queue would sort from top, or would basically sort the queue from bigger values to smaller value. But over here, since we want the minimum distance, we have to sort it from small to big. So then we actually have to define this in reverse. Okay, so that was a pretty long sentence. All right, so QT vector T and greater T. All right. So over here we can just do PQG. We want a pair int. Let's call this Q. Okay, so first we're going to insert our source. Right. Okay, so what we want to do, we know that the distance from anything to itself would be, or from itself to itself would be 0. All right, so remember we still have to have our distance array, so let's call this distance. So we know that the distance from 0 to 0 would be equal to 0. So we're going to do this while there's still stuff in our queue. Let's call X going to be the first element, or this should actually be top, and we want to pop it out. All right. So then what we're going to do is that we're going to loop through each adjacent thing in the adjacent of X second. Let's call our new weight equal to the weight of this plus the weight of this edge, which is going to be y dot second. And notice here that we actually because what we want to do here is that in Dijkstra, since you have your distance array and since you want to have the minimum, then you would basically set everything to infinite at first. So then what you're going to do here is that we're just going to use memset distance, just going to memset it so everything would be a pretty big value. Okay. So this is going to be our new weight. So if our new weight is less than distance of the resulting node, then we're going to update the distance, and then we're going to push new weight and y dot first. All right, and okay, what's the error here? Lambda. Okay, so I don't think I used any lambdas here. Okay, so I did make a simple typo. So over here, actually, so here's a pretty key thing in Dijkstra. So if the current distance, which is going to be x dot first, if this is greater than distance x dot second, then we don't want to do this, because if this, which is our current cost to x dot second, if this is already greater than this, then this is basically redundant to push back new nodes. All right. So assuming that that works, we're going to loop through each pasture. Let's call it total. We're going to add the distance times the number of cows, which is going to be CC of I. And then we're going to return total. All right. So then back here, we're going to try to go from each pasture. We're going to try to place a sugar cube at that pasture. So then let's call our answer, or there should actually be a pretty big value. Min, since you want the minimum answer, the extra of I. So then at the end, we're just going to print our answer. Okay, so let's actually run this. All right. Okay, so that's our extra function. All right, it's running. Okay, 10, which is not correct. So what I'm going to do here is I'm just going to give this temporary value an x, which is going to be the extra. And I'm just going to print from I, answer is x. And over here, we just put x. Okay, so from 1 answers 10, from 2 answers 11, and so on. Okay, so distance of I times CCI. Alright. So what I'm going to do here is I'm just going to print distance of I is equal to distance of I. Okay, so distance of 1 is equal to 2. Distance of 2 is equal to 1, 5, and 4. So if you take a look back here, what we have for 1 is 10154, which is not what we have here. Okay, so for 1, it should actually be 0. Oh, okay, so I guess I made a mistake here. So we're not actually setting distance 0 to 0. There should actually be source. All right, because if we set 0, that's basically not cool, because we don't actually have a 0 in our graph. All right, 8, which is correct. Nice. All right, so I removed my comments and since we're reading from butter.in, stdin, and we're writing to butter.out. Alright, and then up here to submit butter and alright, so let's get here and let me submit that. Alright, so okay. Butter, alright. Okay, so that is correct. If you have any questions or suggestions, you can leave a comment in the comment section below. And that's it for today. Bye.